our meeting. Let me introduce myself. My name is Paal Iversen. I am chairing the BEATA, the steering committee of BEATA. And I'm very pleased to be the host for today's webinar on low and zero emission aviation in the Barents region. The webinar was cancelled just before it was due to be held in Bodø last year in March. After March 2020, we are used to live our lives under the pandemic now, and this affects almost all the aspects of our everyday life. As mentioned in the invitation letter to this webinar, aviation is the most affected transport mode under the pandemic, 90% down compared to 2019, and with a long recovery period ahead. Maybe the level of 2019 will be reached in 2028 or 2029. We will see. However, today's webinar will be forward-looking, focusing on the ways to make aviation a smarter and greener transport mode. We have gathered experts and stakeholders from the 4 Barents countries to share information on ambitions and plans for aviation in the years to come. I am very pleased to note the interest and the willingness from the speakers to share their insights. I do hope the webinar will be informative and inspiring. If some of you are so inspired that you would like to take contact aiming for a future cooperation, I will gladly contributing to connecting people. And I know my colleagues in BEATA will also contribute to that. This is the purpose of the Barents cooperation. I'm now pleased to give the floor to Olav Mosvold from Avinor, Norway, and Jan Petter Steinland from the Civil Aviation Authority in Norway. They will hold a joint presentation. They will touch upon the global as well as the Norwegian objectives for reduction of CO2 emissions in aviation. They will inform us about what's going on and when we will be able to go electric in a larger scale. So the floor is yours, gentlemen.
Thank you. This is Jan Petter Steinland from the Civil Aviation Authority. I'll just take a few words about myself, and then Olav can jump in. And then what we will do, we'll make this presentation in 2 parts. And I will now share the screen if that is all right. And you see my screen all right?
Yes, it worked fine.
Okay, thank you. And so, yeah, Jan Petter Steinland, I'm with the Civil Aviation Authority in Norway here in Bodø, as a matter of fact. And I'm head of innovation and development, and very much engaged in the green aviation sector for the time being. Olav, are you connected?
I am here. Good morning, everyone. My name is Olav Larsen. I'm currently managing Avinor's carbon reduction program, and I'm based in Oslo, Norway. So, greetings from sunny Oslo. Can you take next slide, please? So I'll run through the first 50 slides, and then Jan Petter will do the rest. The point of departure for looking into zero and very low emission aviation is obviously the Paris Accord, and where almost all states in the world have agreed that the global warming should not be higher than 2 degrees Celsius compared with pre-industrial times by 2050. But that also means that we must more or less stop emitting carbon or fossil carbon into the atmosphere. And we have to stop that as soon as possible and before 2050. So Paul mentioned in his introduction that we are, as an industry, the aviation industry, severely hit by the COVID pandemic. But that has not challenged our focus on doing something about the climate or carbon emissions from our industry. So we are working full time on this still, and I know that's the same is the case in many airlines and with colleagues all over the aviation and the environment community. So there are quite a few ways in which one can reduce emissions from the aviation sector. Obviously, the aircraft are getting more and more efficient. Huge investments going into development of that, both motors, but also, or the jet engines, but also the airframes. A second option is to phase in what is termed sustainable aviation fuels. That is fuel that is turnkey ready today, so it can be used in today's hardware, today's aircraft and all the infrastructure at the airports. Jet biofuels, I'll mention that a little bit, and also electrofuels are coming up. But the main theme of today's talk or presentation are the new technologies. It is electrification and using hydrogen for propulsion in the air. So I have only one slide on sustainable aviation fuels, and this presentation will be available after the conference. So I'll just mention here very briefly that this has been available for more than a decade already. The advantage is that it can be dropped into the current aircraft and infrastructure, but the disadvantage is that it's currently very costly and production is low. We've carried out quite a few projects and initiatives in Norway over the last, let's say, 10 years, including reports and demonstration projects. And I would also like here to mention that the Norwegian authorities in 2019, I think, decided that from 2020, 0.5% of all jet fuel uplifted in Norway would have to be so-called advanced biofuels. There's a political goal from the parliament that this should be increased to 30% by 2030. A few caveats to that, but it's still the goal. And several other countries are considering the same. Sweden and Finland are present here today in the conference. There are discussions on this in New Zealand and also for a EU-wide mandate. And also so-called electrofuels are coming up and coming. It's fairly high on the agenda now, but that will have to be a topic for a different presentation, a different conference. So what do we mean by electrification? We have defined it as an aircraft with at least one electric motor for propulsion in the air. And that electric motor will need to get its electricity from somewhere. And that could be either a fully battery electric energy source. It could be variants or different types of hybrid solutions where you have both battery, but also some kind of generator based on liquid fuel. And the third option that is getting more and more attention is adding a fuel cell, which is an advanced battery in many respects, running on hydrogen or some very hydrogen intense dense material, providing the electricity for the electric motor. We have been looking from Avinor side, we've been looking into this since 2010, but more, I would say, more systematically, and spent actually quite a few calories and resources on this since 2015. And the reason for 2015 is that in, I think it was July that year, Airbus flew this little aircraft across the English Channel. That's a flight that's 72 kilometers long, and that's longer than many of the domestic flights on the short-haul network in Norway. So we realized that this could be an interesting technology path to monitor. There are currently more than 200, as far as we know, projects around the world working on electrifying aircraft of all sizes and shapes. In the remainder of my part of the presentation, I will pinpoint some of these for you to get an idea about what is going on, so the whole sort of spectrum. But obviously there are many more I cannot talk about in this short speech. So this is an example of an aircraft that is already flying. It's a 2-seat aircraft with a 130-ish kilometer range, but it's very light, and it is designed for training, pilot training, and also for some recreational use. There are a couple of producers or OEMs in this domain, and this is also probably the segment where it is most easy to get these aircraft certified. What is maybe, there are a lot of uncertainties here, obviously, but it is likely that what we will see first in regular passenger traffic is a 19-seater, and that has to do with the certification schemes. Up to 19 seats aircraft looking maybe like this. This is a Swedish aircraft designed in Gothenburg by a Swedish startup. It's fully battery electric, but it is also likely that one could see aircraft of this size and this shape with, let's say, fuel cells, but still with fully electric motors, and they will have a quite limited range. That's what we expect. Another example is a hybrid aircraft. This is a French producer, Volt Aero. They are test flying their systems in a small in the aircraft on the right hand side of the screen. It is flying. It has both electric motor and the fossil engine. And on the left hand side is what they aim to actually produce in different versions, somewhere between I think it's 3 or 4 different models with 4 to 10 seats depending on the model. And as you notice, it's only one propeller in the rear of the aircraft, but that propeller is driven by a motor that has both electric and fossil. So this is a hybrid solution, and the advantage with hybrid solutions is that they are obviously increasing the range of the aircraft while we're waiting for batteries to get better. So what one could expect to see perhaps in the next 5, 6, 7, 10 years are relatively small aircraft certified for regular passenger traffic, perhaps with a range of up to 200-300 kilometers, depending on the battery development, as I mentioned, and also the design and the architecture of the aircraft. So we've taken here, put Bodø, because that was where this conference was supposed to be held some months back, and looking at the distances. But if you sort of side shift all these circles, you'll see it cover quite a lot of the Barents region, actually. And if the range gets a little bit longer, which I'll get back to now in the next couple of slides, it will actually cover quite a lot of the Barents region. And this is where hydrogen sort of comes into play. Hydrogen has been gaining a lot of attention and momentum in the aviation industry for the last, I would say, the last couple of years, and especially since summer. Mind you that hydrogen is a very convenient energy carrier. It is already used in production of biofuels, sustainable aviation fuels, hydrotreating the fuels. It is vital in electrofuels that I mentioned in the introduction to this talk. But what we'll talk about here is hydrogen used in fuel cells, and then it will be what we've already defined as an electrified aircraft, and also coming up direct combustion of hydrogen in jet engines. And there are a lot of hydrogen efforts going on worldwide. I believe most countries in the world these days have some kind of hydrogen strategy, and there's a lot of research and development money going into it as well. Cirro Avia has been around for 3-4 years perhaps. We met them a couple of times. They are already flying a small Piper Malibu. They're originally from California in the US, and now based in Cranfield. And they flew with first battery electric to test their systems. And this fall of 2020, they also started flying on with a fuel cell as the energy source for the electric motor. It's a very exciting project, and it will, using hydrogen will also add, as I mentioned, range to these type of aircraft. But what has maybe had a knock-on effect on a big part of the aviation industry is that Airbus, the European aircraft manufacturer, in September came out of stealth mode with their plans for a zero emission aircraft. They are stating that this could be, their goal is that this should be available in the market by 2035, so that's 15 years from now. And they are looking at hydrogen as the main energy carrier. They have been very, they've been very eager to tell that these are examples of architectures of what these aircraft can look like. They will not necessarily look like this, but this is sort of some projects and some plans they are looking into. These aircraft will typically be able to replace the single aisle aircraft that is already flying on a regional base regionally in Europe, and with a range of up to 2,000 nautical miles that will cover all intra-European flights. They're also looking into other architectures, and here is their take on a fuel cell aircraft. It's a relatively small aircraft depicted here, something like what is today ATR 42 or the Dash 8s. It has 6 motors in this design, and these are so-called pods, and each of them has an electric motor and hydrogen storage. So this is an electrified aircraft as we have defined it. So it will be totally emission-free, and it will probably also be a lot more quiet and emit less noise than the current technology today. Burning or combusting hydrogen in passenger aircraft is not new. It has been done in Russia in the 80s, and this is a Tupolev 156, I believe. I think they also studied a Tupolev 155. And apologies to our Russian friends if I mispronounce the Tupolev. Hydrogen has also been used in the space industry and also in the defense industry for a number of years. So there is quite a lot of experience in using hydrogen as an energy carrier. So as I mentioned, if one can use hydrogen as an energy carrier, the range will be extended quite a lot. Here is 1,000 kilometers, so that's approximately 500 nautical miles. It's said in the presentation from Airbus that they could reach up to 2,000 or 4,000 kilometers range with hydrogen aircraft, and I think that is extremely promising for a zero or very low emission aviation future in Europe. This will obviously have consequences also for the airport infrastructure. From Avinor's side, operating most of the airports in Norway, we're looking into this and preparing for that development. We're looking into what will be the needs for charging, and also how will supply and storage of hydrogen affect our airport operations and planning for the future.
Thank you, Olav. Then it's back to me then, Jan Petter. What we wanted to do now is to have a look at some of the key challenges and also some of what we think is a way forward to improve innovation, speed and quality. We will go through some of these points. These are results of, I would say, the last, we've been working several years, but the last 2 years, a lot of things have happened. We have been doing reports, analytical work, and both nationally and internationally. A lot, of course, European based collaboration. And what I will be talking about now is our summary or our total evaluation of what are the main issues. So we'll kick off by talking about the key challenges that we have identified. And there are a number of issues, but these we believe are very significant. So the one key challenge, of course, is that developing new technology, including also the use of new fuels, is expensive and complex and time consuming. And it is because of, I would say, three reasons for that. It's the level of safety that we take for granted, and new solutions, new aircraft, it's not acceptable that they are less safe. So we have to make sure that we maintain high level of safety. The other thing is that the aviation is thoroughly regulated. So we need to maintain the regulation as we go along, but this again, it is time consuming and could also be expensive. And finally, it's the laws of physics, the weight issues. Everything will need to be aerodynamic and it will need to carry payloads. And of course, while everything needs to be lightweight. And this is something that is specific for the aviation sector, obviously. And this is also why we know that it is very expensive and time consuming traditionally. So now we have to come up with ways of not cutting corners, but increasing speed. And of course, developing parts of these technologies is one thing. So develop a new propulsion system, or develop a new design or new power electronics. That's one thing, but integrating every technology in one aircraft platform is very advanced. And of course, this also needs to be commercially viable to make sure that you can actually grow a business. Both you're able to sell the aircraft and you're able to operate the aircraft. We also see that we expect that among other things, hydrogen, maybe e-fuels, more biofuel, some of these fuels will require new infrastructure or new ways of both producing, transporting, and deliver to the aircraft. And this could potentially require significant investments in infrastructure. One of the things that can be done or needs to be find answers to is how we can join forces and join hands in defining common standards and also taxonomy, i.e. a classification system, so that we have common references to what is, for example, what is a green aircraft, what is the charging infrastructure. The more interoperability and the more joint standards and taxonomy, the better it will be. Some things are already happening in the EU system on taxonomy, but there's a lot of work to be done. We need to have focus also on avoiding critical bottlenecks. And this could typically be to make sure that, that regulation is not lagging behind. Very often in innovation processes anywhere in society, when you talk to the people who have been working with innovation, they often, you can hear that they say, we got the product ready, or we had a good concept, but the regulation was lagging. Now, it's important with regulation, but this is just an example that we see the need for regulation we try to develop it in parallel to technology development. So it could be a push and pull process. And this is just one example of how we need to analyze and identify critical bottlenecks before they occur. And of course, finally, what has happened the last year is obviously COVID-19. That we have seen that one effect is already that there is a need for more public support. As Olav was saying, that the COVID effects on top of everything else for the airline or the aviation industry speaks or points to increased public support or support from governments and public financial arrangements to make sure that we keep the pressure up. So we need to be very aware of that as well. All right, so to us, and we have been collaborating and in dialogue with a lot of players in the theater, both from industry, manufacturing, airlines, financial sector, energy sector. And we think that if we should accumulate all this, all that we have experienced, that we need to accelerate innovation. And our experience also is that we see that this as attacking on three axes that are the main issues. We need to address the complete aviation system. We need to create better arenas for collaboration, both and not just nationally. It could be European collaboration, it could be a regional like the Barents or other regions collaboration, or global collaboration. Of course, the bigger the collaboration arena, the more difficult it is to do it in practice. And the last key issue would be to create more effective and efficient innovation. A lot of resources are being spent on maybe on products or concepts that could have been run differently and then maybe get results quicker, or even stopped projects quicker because of knowledge. So, but I'll touch into each of these as we see that these are the main items. So in some comments on addressing the complete aviation system. So we're saying that we cannot just focus on the aircraft itself, but the whole system around the aircraft. But a little bit back to the aircraft. There are a number of issues that need to be resolved in this. It's not just, as Olav has been talking about, the propulsion system, but there are a number of challenges. It's heat, it's cold, it's magnetism, it's high power. And the most difficult of all, as I said, is probably integrating all systems into one platform. New materials, new aerodynamic design, because if you carry in hydrogen, which needs bigger volume than kerosene, today's jet fuel, then you need to change the design. And then, of course, you also need to, in parallel, be looking at the airspace structure, because you may need the new technologies may require that we, for example, have different takeoff or departure procedures or profiles. We can have different approach profiles where you need to maybe have a steeper approach to regenerate power. So this could mean that the new technology will also require new airspace structure, as well as management. An example would be that maybe new aircraft will be flying at different speeds, at different altitudes. We may even want to give priority to low or zero emission aircraft as an incentive. And that's why we're saying that also airspace management could be a significant player in this. Obviously, the ground infrastructure is how you, what kind of charging infrastructure do you have? Where do you store the hydrogen? If you're storing liquid hydrogen with minus 253 degrees, you need to store it and have the infrastructure for that. Operations, how do we operate the aircraft? How do we train the pilots? How do we operate them regarding turnaround times to make sure that we can utilize a new aircraft with new technology with short turnaround times? How do we maintain this aircraft, etc.? Regulation is also, as I already touched on, very significant part of the aviation system to make sure that we both identify the gaps, what kind of new regulation is needed, and also that we are being focused on giving enough priority to give the innovators or the manufacturers a regulatory sandbox, for example, to operate in, i.e. a theater where they can test new technology safely and integrated with other players. And then finally, addressing also the societal needs, because new technology could mean new opportunities for the society. It could also be new challenges. It could be that aviation could have a different impact on the total mobility system. And this is very important to develop and analyze as we keep developing technology for new aircraft and new concepts. So the other main part we have identified is that we need to create arenas for collaboration, because I think the word that keeps coming back with every player we have been working with is, and they all say this, we need to collaborate. Innovation will need to happen together with different players. Even the major companies like Airbus is very clear that we need to innovate together with other organizations, other parts of the industry, even other sectors where there is high competency. So in this arena, we need to make sure that we can engage both the manufacturers, of course. We need to have the operators connected, because like in Norway, Widerøe is our main domestic player, especially regard to regional aviation with the shorter distances. And of course, their knowledge with many decades of operation is significant in developing new technology. The authorities, also a very clear message that if we need to connect the authorities like ourselves to this process, that's why we also are thinking, we hope, innovatively about our role in this. And authorities should be connected to the process early. Research, obviously, that's more a given, but we also see that now may be the time to get closer ties between the energy sector and the aviation sector, as well as also connecting to the financial sector. Just as an example, the EU taxonomy on sustainable investments is now underway. The first regulation is already in place, and now we're looking at further detailed regulation. And this could be very significant in identifying what are green investments when you talk about aviation, and also connecting to this different, whether it's private financial sector or it's the more public financial sectors. And others could be typically environmental organizations, even, to get their knowledge and to also have their buy-in into the processes, because it's very much about identifying what is really green development, and to avoid any greenwashing or any to avoid that aviation is being put up there as a brown industry or not being sustainable enough. All right, and just to end this part of it is just looking a little bit at how we can make the innovation processes more effective and efficient. And as we already said, that for a lot of not just the big players, but also for the small and medium-sized businesses and organizations, it's very important that they have access to the aviation ecosystem and competency. And because this is where we know the innovation will take place. So just giving these, maybe particularly the small and medium-sized businesses and organizations, access to the ecosystem will provide them with a lot of knowledge on an opportunity to improve their innovation processes. We need to continue the work to establish relevant incentives. In this year's the budget in Norway, the first incentive for really motivating the use of zero emission or low emission aircraft is a budgetary input to exempt a passenger tax if you fly low or zero emission. We're just in the process of defining what that will look like, but it's a very important example, I think, on sending clear signals that low or zero emission aviation will be given priority and also given incentives and rewards. This is very important to stress also for the political level. We need to work on environmental analytics, understanding not just the CO2 emission challenge and decarbonization, but also, for example, looking into the non-CO2 effects of aviation, i.e. particles high up, or the production of contrails, which have an equally large part of the climate impact as the CO2 itself. There are uncertainties, but the overall view on that is that these are both very important areas to address, and there's a lot of work that needs to be done. And this is one of the conclusions, that we need to work on the environmental understanding of what is having which effect, so that we can the technology can and the fuels can follow the knowledge. Of course, digitalization and the digital capacity has increased vastly, but we also need to look into aviation. How do we then use this phenomenon to support innovation? How can we pave the way for a more digital testing and development of new equipment, new concepts? For each year, this becomes more and more international, and it's very significant for the speed as well. We also believe that coordinating the efforts towards aviation on the financial support is key. It could be connecting the financial, as I said, connecting the financial institutions to the aviation system. But it could also mean that we try to establish aviation and increase the investments from the political side as well. As, for example, in Norway, I mean, we are so dependent on aviation that making sure or working to make sure that we get enough incentives in place is important for us. And of course, there's overarching that we need to increase the coordination and the collaboration, both nationally to make sure that we're well coordinated, but also internationally, whether it's European or global collaboration. And this, we try to identify how we can do that. All right, so what's about the timeline? We were challenged also to say something about that. We have already told you that in our perspective, it is there is a lot of uncertainty, and today mostly the different manufacturers have different claims. They're saying, okay, we will have an aircraft ready by 2026 or 2028, etc. But we see that there are still unresolved issues. It's not just that we know exactly that is a relevant timeline, because especially when you look at certifying new aircraft, new technology, there is a degree of uncertainty. And as Olav has been talking about, there's also a lot of work that needs to be done to see which technology will actually have the final sort of market impact. And we expect there could be several technologies, both all electric, battery driven, or all electric with fuel cell combined with batteries, or hydrogen or e-fuels, or more biofuel, etc. But given all this, we would say approximately that we expect smaller aircraft up to 19 seats somewhere in a window between 2025 to 2030. And let's say if there are old aircraft that are being retrofitted with new drivelines, that could be earlier, but this is what we expect with new designs, new aircraft. And for the regional aircraft with more than 19 seats, because that's a different kind of certification system, it's a little bit, it's more complex. And then we also expect to see these bit larger aircraft by 2030. And then we see that, for example, Airbus is saying that by 2035, they expect to be starting to be able to replace some of the 737s or the Airbus Neos, etc. So this is concerning the timeline. All right. Finally, some couple of concluding remarks from our side. We of course we appreciate the opportunity to talk to you today. We had discussion prior to this what the concluding remarks should be, and the one obvious one is that the Barents region is totally dependent on aviation. It's not just Norway. There are long distances. We have a lot of joint challenges, and we need to keep a strong aviation system in this region. We know that the greenhouse gas emissions must be mitigated. Yes, of course, most players, I would say, or many players in the aviation system today is very concerned with the COVID-19 and are focused on starting their business up and again, or keeping it alive. But then as soon as things are rolling, and also due to more public support, more support from governments, the immediate concern then after that and in the following years will be the decarbonization or the reducing the climate impact. Sustainable aviation fuels, as Ola said, it's already there. It can help us to fill the gap until we have new technology implemented in aviation. And the electrified passenger aircraft, whether it's on batteries alone, whether it's with a fuel cell or other hybrid combinations, they will become reality. And hydrogen is today expected to be part of the solution. Every player we have talked to is also having hydrogen on their map and seeing this as one of a part of the solution. And of course, I think the final word, if any, is that collaboration is key. And it's not easy. I think that may be the most difficult issue of all, is to find ways to collaborate that is effective and efficient, but it's definitely needed. So with that, I will say thank you for being given this opportunity today. Back to you, Paul.
Thank you very much, Jan Petter and Olav. You have given us a very comprehensive presentation, and you raised a lot of interesting topics. We do have some time to comments and questions from the audience. So if you have questions or comments, you are welcome to raise your hand or use the chat. Before we receive any requests for the floor and questions, I would like myself to try to connect the incentives for promoting these solutions in aviation, and we compare the incentives the Norwegian government has done to the electrification of the cars. We have very strong and radical tax schemes, which works. We have managed to get a huge share of electric cars in the fleet, thanks to a lot of incentives. Will the incentives, how important are the tax or the economic incentives for speeding up the electrification?
Well, I may start off then, Olav. Feel free to support, because this is it's a big question. But obviously, due also to the COVID-19 situation, the incentives may even be more important. But the overall feedback that we have been picking up is that there's a clear need for predictability, that there are incentives, that we need a row of incentives that can be addressing each of the phases. So right now we're quite an early phase, so then you need one set of incentives. And then when you get to the medium phase, where you start to, so the first phase is where you develop the underlying technology, the basic technologies. And then it's a phase where you approach the product, try to get the product, and testing the concepts with prototypes, etc. And then there's the last phase towards commercialization, where you put it into use, where you have your actual first flights between two cities with a commercial airline. And these phases require different incentives. And then one can, so of course, a lot of the research projects are aimed at the first phase, developing technologies, and then you make choices and you start building aircraft. And we also see some of the projects are going in towards the second phase, but there's also this realizing that we need predictability and long-term incentives also. So what the Norwegian government has done with sending the signal that when we have a product and we will start flying, then the taxes will be reduced. We think that is important. It's a little bit difficult to say how important it is in this phase, but it has been requested also by both the operators and the manufacturers, and we need to see long-term incentives. So I think one point is, as I said, that we have incentives are working all these three phases, if you like. And for example, also in Norway, we have this Enova as an organization. They are providing financial support when to reduce the risk when you invest into new technology, because we know the first aircraft will be expensive, and it could be different technologies. We don't know which technology that is most significant or will be most significant 10 years from now. But we have already incentives saying that, okay, the state is willing to pitch into and reducing the risk of early investments. So it's also a matter of reducing the risk, both for the manufacturers, but also the operators or the airlines buying aircraft. So a lot of things here, but and also like you, Olaf, to pitch in if you have any further comments to that.
No, I think you've covered that pretty well, and I will also post a link to a report in the meeting chat where we discuss policy incentives and instruments more in detail, so you can have a look at that. But I think again, Jan Petter, you've covered pretty much what I would like to say as well.
Just one final comment, Paul, to your question. As you talk about the economic incentives, and yes, obviously, as I said, in these COVID-19 times, they even increase in significance. But also the value of setting goals, that we set political goals, is also very important, which is it's not, we can say, it's not money in the bank, or it's not money in the pocket of the developers, but it's very important to signal what the societies are, or the politicians are, what their ambitions are, and whether they are expressing this, because it gives a lot of help. And from our side, from authority side, we also feel that one reason for us to be engaged is that we can also provide some credibility to the process, so that because we believe that if we say together with other authorities, say that, okay, this process, this innovation process, is something we think is well-founded. They have the right competency, or we are also looking at the safety aspects of it. That's also one way of providing sort of a reason for being able to increase the speed of the innovation. So these are just examples of how we can have different incentives and different actions that can improve things.
Thank you very much. I have received a couple of questions. One is concerning the market situation, and I assume this is the market for aviation services in the Barents region. Is it enough with the market you have, or will implementation of new vessels open up for more aviation possibilities in the Barents, do you think?
I could have a go on that, Jan Petter, and then you can chime in. I think I would actually like to cover both of the questions in the chat in the same answer. It's a question from Ritva here as well,
yes.
about how the European countries and the European aviation industry is doing compared with the rest of the world. And I think it is fair to say that Europe is, for many, is really actually taking the lead here. That said, there are very interesting incentives and projects going on in the US and China as well. Very interesting, but I think the density of projects and also the emphasis that governments throughout Europe is putting on clean, sort of zero or very low carbon solutions for the aviation industry is putting Europe in sort of the front of the pack. We could discuss this for a long time, and probably someone would disagree with me, but at least that is my opinion after working on these issues for the last 5 years. And then the market. depends a little bit on what you mean with the market, but I think it is also fair to say, and I hear that even more often, has been coming up in debates and conferences like this, actually, especially over the last year, that Scandinavia and the Nordics are looked upon as a possible first market. And in that respect, I would say that even our market is probably not big enough to justify a totally commercial sort of development of a new aircraft, because the OEMs, the aircraft producers, will have to obviously sell a number of aircraft to make a little bit of money on this journey. So they will also design their aircraft to fit a bigger market than just the Scandinavian market. So these are the considerations that they will have to take into account: the range, the size, all different issues, and that will probably also impact their choice of a propulsion system, whether it's fully electric, hybrid electric, or fuel cell. So there's a lot of considerations going on within the OEMs at the moment. But I also think it is fair to say that the first aircraft producer that can actually bring a zero or very low emission aircraft to the market will have a huge advantage, most probably. So we're excited to see who will win that race.
I also interested in the demand for the customer and the routes. I mean, are they still? Do you have to build up a bigger route net, or is it? Can you use what you have?
The demand from the customer, well, the general customer in aviation is fairly price sensitive. I think that's so. We do not expect that all passengers would voluntarily pay more to fly zero or low emission. The interesting thing with these solutions is that they could possibly in the future provide cheaper tickets as well, because electricity, is taking that as an example, is a lot cheaper than kerosene, and also maintenance costs related to electric motors are expected to be less than jet turbines, so that will remain to be seen. And in terms of routes and connectivity, the route network today is developed based on the hardware available. So the number of seats in the aircraft the airlines are operating. So if there are different size aircrafts and perhaps with a different cost structure, that could definitely impact the route network and also then the connectivity of the region. So with smaller aircraft, one could perhaps expect to see more frequent flights, so more flights per day, perhaps, and also it could make some destinations more attractive, and you could probably also see more direct flights. But then on the other hand, with smaller aircraft, you would, at least in the beginning, still need one or two pilots. So there are some costs that cannot be reduced. So this is all part of the big equation, I guess, when both OEMs and airlines are looking into these issues.
Thank you, Olav. We do have more questions coming up on the chat, but we have to let speakers from the other countries in. And if Olav or Jan Petter could look into the questions from Oddgeir Danielsen, you can maybe answer in the chat.